Today, whales are the largest animals on the planet, and perhaps the largest to have ever lived. Modern whales, or cetaceans, can be broadly divided into two groups: the filter-feeding baleen whales, or mysticetes, and the toothed odontocetes. However, cetacean diversity was once much greater, as many groups have sadly become extinct. In this video, I would like to put the spotlight on some of the more obscure members of the cetacean family, and they are truly extraordinary. Along with the extinction of the non-avian dinosaurs at the end of the Cretaceous period 66 million years ago, the carnivorous marine reptiles were also wiped out, leaving many vacant niches in the world's oceans. Much like the reptiles before them, a group of terrestrial mammals took the plunge and gradually became more and more adapted to an aquatic lifestyle. The very first whales were the Pachycetids from the early Eocene epoch around 50 million years ago. The group's namesake, Pachycetus, means Pakistan whale, and you can probably guess where it was discovered. It looked somewhat like a wolf and was of a similar size, but was actually more closely related to the herbivorous hooved ungulates, especially hippos. It was a carnivore with fully functioning legs that was thought to have lived in and around rivers and lakes, hunting fish and possibly even small terrestrial prey, similar to a crocodilian. Despite appearing so radically different to cetaceans as we know them, a defining trait of this group is actually their ear bones, specifically the bulla, which replaces the eardrum as it is more effective for hearing in water. Whilst very small and nowhere near as specialised as later forms, Pachycetus' skull did feature a bulla, suggesting it was adapted for hearing underwater, just not as effectively as its later relatives. Whilst evolution is not a linear process with goals, if we look at the cetacean family tree through the lens of leading towards modern whales for the sake of this video, the next step, as it were, would be the Ambulocetids. The group's namesake genus, Ambulocetus, which means walking or running whale, is most famous for its walking with beasts appearance in Germany of all places, despite also being known only from Pakistan roughly 49 million years ago. Speaking of walking with beasts, its portrayal of swimming still holds up over 2 decades later, as they were thought to swim in a strange vertical undulation like an otter, but without the flattened tail flukes. It would have lived in the coastal waters around the Indian subcontinent, which was a separate landmass at the time in the ancient Tethys Sea that separated Africa from Eurasia. Oxygen isotope values found from their fossils indicate that they could tolerate a wide range of salinities, suggesting that Ambulocetids represented a transitional form from fresh to saltwater in cetacean evolution. Some later cetaceans would return to freshwater, but more on that later. The bones of Ambulocetids show osteosclerosis, dense bones which are seen as an adaptation for aquatic life as they provide ballast and counteract their buoyant air-filled lungs. The degree to which Ambulocetids could move on land is a matter of debate, with some studies finding they could move on land but were not very effective at doing so, and others finding they would be incapable of land movement. The next group to emerge were the Remingtonocetids, named after zoologist Remington Kellogg, who specialised in marine mammals. They were a very obscure group that seemed to represent when cetaceans became fully independent of fresh water based on oxygen isotopes from their fossils, dated to around 48 million years ago. They also showed a reduction in the semicircular canals of the inner ear, which aid in balance in land animals, but have little use in aquatic ecosystems, representing further specialisation into a fully aquatic lifestyle. This group seemed to be a more experimental phase in cetacean evolution. They generally had elongated snouts, which is especially evident in the genus Cuchicetus. The genus Rhyonistes is significant as it was found in Egypt, representing the earliest known whale found outside of the Indian subcontinent, suggesting that by this stage, cetaceans were capable of crossing fairly large ocean distances. The next to emerge were the Protocetids around 47 million years ago. This group was the most widespread yet, being the first to have crossed the Atlantic, with genera being found in North America as well as Peru, suggesting they had also entered the Pacific too. The genus Myocetus, which means mother whale, was named after a specimen preserved with a fetus still in the birth canal being born head first, suggestive of it being amphibious, as a head-first birth in water would risk the newborn drowning before leaving the birth canal, suggesting childbirth was carried out on land by this genus. An important feature of Protocetids were their nostrils that, unlike previous groups whose were positioned at the tip of the snout, were positioned halfway up the snout, a phenomenon known as nasal drift, representing a transitional state from the basal nostril position to the blowholes of derived cetaceans. They likely had strong webbed feet, and some may have also had a tail fluke. This group and the following one mark the first of 3 major cetacean adaptive radiations. The next group to emerge around 43 million years ago were the most famous of the early whales, the Basilosaurids, also famous for its namesake Basilosaurus appearing in Walking with Beasts. Their name is a bit of a misnomer, as it means king lizard, as when their remains were first uncovered, they thought they were those of a giant sea serpent. It was the first extinct whale known to science, but wasn't realised as such until after it was officially named. As such, despite Sir Richard Owen, the naturalist who coined the term dinosaur, attempting to rename the genus Zeuglodon, meaning yolk tooth due to its double-rooted teeth, the rules of zoological nomenclature dictate that the first name coined for a species takes priority, so Basilosaurus persists. Naming shenanigans aside, Basilosaurids were the first obligate aquatic cetaceans known, with their tail vertebrae indicating they possessed tail flukes like modern whales. Despite this, they still retained tiny external hind limbs, speculated as being used as claspers during mating. Freed from the constraints of living on land, some would grow to tremendous sizes. Within the family Basilosauridae, historically, there were 2 distinct subfamilies, Basilosaurinae and Dordontinae, but in 2022, a 3rd subfamily was coined, Pachysetaeinae. Within Basilosaurinae, Basilosaurus itself was enormous, thought to have measured up to 20 meters long. It was thought to have been an apex predator, preying on large fish and other smaller whales. It was long thought to have been the largest animal to have evolved since the Cretaceous at that time. However, this title has been challenged as recently as 2023 with the description of another colossal basilosaurid, Perucetus. It was a Pachysetaeine, but is only known from fragmentary remains. Whilst estimated at comparable lengths to Basilosaurus at around 17 meters long, its bones were significantly denser, resulting in weight estimates from as low as 85 tons to as high as 340 tons. However, this incredibly high estimate has been questioned. For reference, the largest whale alive today, and possibly the largest animal to ever live, the blue whale, has been estimated to weigh up to roughly 200 tons, most of which is from the blubber. Perucetus is thought to have lived in shallow coastal waters and to have been very buoyant, similar to modern manatees, though unlike them, no herbivorous cetaceans are currently known. Because the skull is unknown, the diet and feeding method of Perucetus can only be speculated. One hypothesis suggests it fed on mollusks and crustaceans on the seabed, similar to modern grey whales. The 3rd subfamily, the Dordontines, were generally much smaller and more dolphin-like, though lacking the melon organ modern toothed whales use for echolocation. It has been suggested that they may in fact be ancestral to all modern cetaceans, but this is debated. All the cetaceans we've looked at so far can be classified as archaeocetes. At the end of the Eocene epoch 34 million years ago, an extinction event occurred, known as the Grand Coupure, in which the Archaeocetes became extinct. It is thought that around this time, at the end of the Eocene, the two lineages of modern cetaceans branched off from the Archaeocetes, the Mysticetes and the Odontocetes, sometimes collectively called Neoceti. Let's talk about the baleen whale Mysticetes first and how they ended up becoming possibly the largest animals in the history of the planet. The end of the Eocene and the start of the Oligocene marks the beginning of the Cenozoic Ice House, a period of glaciation occurring at the poles, causing global temperatures to gradually drop, eventually resulting in the Ice Age that began around 2.5 million years ago and continues today. These changes to the climate have been hypothesized to have heavily affected the evolution of cetaceans and in different ways. The isolation of Antarctica at the South Pole led to the formation of the Antarctic Circumpolar Current, the strongest ocean current on the planet that encircles the southern continent. This not only causes cold waters to encircle Antarctica, causing glaciation, but also the cold, oxygen and nutrient-rich waters to then be transported from the South Pole around the globe by other currents. Plankton are plentiful in these waters, providing the base of the ocean food web for larger creatures to feed on in vast numbers, such as krill. These vast swarms could then in turn be fed upon by larger creatures, so animals well adapted to bulk feeding on these organisms would have a rich and plentiful food supply, and as the climate became colder and colder towards the Ice Age, this effect would be enhanced, eventually leading to the largest animals alive today, the Mysticetes, or baleen whales. The earliest members of the Mysticetes are dated to the late Eocene around 36 million years ago. The oldest known Mysticete is the genus Mystacodon, discovered in Peru. Unlike modern Mysticetes, Mystacodon had functioning teeth. Despite being a baleen whale, it is unknown whether Mystacodon actually had any baleen. It was around 4 meters long, considerably smaller than modern Mysticetes and some of the larger contemporary Archaeocetes at the time, like Basilosaurus. Its head was much flatter than those of the Archaeocetes, suggesting that it had a weaker bite. Scientists have interpreted this as an adaptation to suction feeding, suggesting it was a bottom feeder that fed on small animals in the substrate. This is seen as a transitional feeding method between the more predatory hunting of Archaeocetes and the filter feeding of modern Mysticetes. Another Eocene Mysticete was Lanocetus from Antarctica. Size estimates range around 12 meters, and whilst it was originally interpreted as a filter feeder like modern Mysticetes, it is thought to have lacked baleen and may have been a more raptorial hunter as well as a suction feeder. Moving into the Oligocene, the extinction of the Archaeocetes meant that many niches were now open in the world's oceans. This marks the second cetacean adaptive radiation. Despite being younger than Mystacodon and Lanocetus from the Eocene, the early Oligocene-aged Chironodon from North and South Carolina is considered the basalmost Mysticete, appearing very similar to the Archaeocetes, but the skull was wider and showed very loose sutures, suggesting it could possibly expand, similar to modern baleen whales. A Mysticete lineage that appeared in the Oligocene were the Aetiocetids. So far, this group has only been found in the North Pacific, but they represent the next step towards modern Mysticetes, as they were thought to have had both teeth as well as the first known example of baleen. It is unknown whether they fed like modern Mysticetes, bulk feeding and filtering out small animals such as fish and squid, but using their teeth as a sieve as well as baleen. They may also have employed a mix of modern Mysticete filter feeding, as well as the more raptorial predation of earlier whales. This group appears to have become extinct at the end of the Oligocene. Another lineage of basal Oligocene Mysticetes were the Mammalodontids. These are only known from late Oligocene Australia and New Zealand. This family consists of only two genera, Janjucetus and Mammalodon, and were both only around 3 meters long, similar to the size of modern bottlenose dolphins. They They appear to be more basal than the Aetiocetids, lacking baleen and having large, widely spaced teeth. They are thought to have either been raptorial predators of larger prey, or may have utilised a form of suction feeding similar to modern odontocete beaked whales. Perhaps the last group of mysticetes to evolve outside of all modern groups were the Eomysticetids. They first appear in the fossil record in the late Oligocene, and like the Aetiocetids, they appear to have had some baleen, but not wholly along the length of their jaws. Scientists believe Eomysticetids had baleen in the backs of their mouths and had either teeth at the front or lacked teeth entirely. This is most easily seen in the genus Wahoroa from late Oligocene, New Zealand. Scientists speculate that they may have fed in a similar fashion to the ram feeding of modern right whales of the family Balenidae. The following Miocene epoch is when cetaceans attained their greatest diversity, representing their third and final adaptive radiation, and is when all the modern mysticete families first appear in the fossil record. They are the Balenidae, consisting of the bowhead whale Balena mysticetus, and the right whales of the genus Eubalena. The Balenopteridae, or rorquals, consisting of the genus Balenoptera, which include the largest whales, such as the blue and fin whales, as well as the genus Megaptera, the humpback whale. There is also the Estrictidae, which is represented only by the species Estrictius robustus, the grey whale. Among the most successful and widespread mysticetes in the Miocene were the Cetotheres. They completely lacked teeth and are thought to have had baleen plates like modern baleen whales. A 2012 paper has even suggested that the modern genus Caperia marginata, the pygmy right whale, which has traditionally been placed in its own family, Neobalenidae, may in fact be the only surviving Cetothere. The only way Cetotheres differ from modern mysticetes is in terms of size, as they rarely exceeded 6 meters in length. It is thought that baleen whales didn't achieve truly enormous sizes until the later Pliocene and or Pleistocene epochs, when the climate had grown even colder and the highly seasonal upwellings of nutrient-rich deep waters at the poles facilitated large body size to travel vast distances to migrate to where food was most plentiful. However, another aspect that may have influenced their size was not their prey, but rather their predators. The most famous of which, of course, being the largest shark to ever live, Megalodon. Due to this species' genus assignment being very fluid, I'm just going to call it Megalodon. With such rich pickings for both the sharks and the mysticetes, it's no surprise their fossils are so plentiful. Sharks were not the only predators of mysticetes, however. They would have also been hunted by members of the other group of neocetes, the odontocetes, or toothed whales. What sets them apart from the baleen whales, aside from dentition, is their use of biosonar, or echolocation, to communicate and to locate prey, using the unique melon organ, a mass of adipose tissue in the heads of odontocetes thought to be used for amplifying, modulating, and focusing their vocalizations. Similar to how the cooling climate is thought to have influenced the evolution of the mysticetes, it has been suggested that the evolution of biosonar in odontocetes was an adaptation to locate prey as the oceans became colder and murkier due to cold water being more hospitable to microorganisms and a poorer solvent of materials. Sight, therefore, would have become less useful, and so instead further developed their sense of sound. This also would have allowed them to dive into deeper, darker water, opening up new hunting opportunities. Contrasting with the mysticetes' comparatively clearer taxonomy and internal relationships, the odontocetes are a bit all over the place. There is a lot of homoplasy, that is, separate groups converging on similar adaptations and lifestyles. The first major group of odontocetes to emerge were the xenorophids, which interestingly are only known from Oligocene North and South Carolina. They would have resembled modern dolphins with long beaks and sharp teeth, a bulbous head housing the melon organ, and utilised echolocation to hunt fish. as is suggested by the genera Cotylocara and Echoveneta. Interestingly, within this group, the genus Inomorostrum had a very short beak and lacked teeth, suggestive of a diet of soft prey such as squid, showing that this group was already diversifying early in its history. Living alongside the xenorhophids was the genus Ankylorhiza, a more derived odontocete with proportionally large teeth and a powerful bite, thought to have been an apex predator similar to modern killer whales. At around 5 meters long, it was one of the largest toothed whales of the Oligocene. It was thought to be a fast swimmer and the first to specialize in preying on large animals, chasing down its prey and piercing them with its conical teeth. From this point is where the taxonomy of odontocetes gets messy. The main reason being that many lineages are referred to as dolphins. The name dolphin does not refer to a natural group of organisms, but rather is a vague descriptor for a body form many unrelated cetaceans have. This is called a grade in cladistics. Nowhere is this more apparent than with river dolphins. All modern animals referred to as river dolphins are thought to be the result of unrelated lineages of formerly marine cetaceans becoming isolated in freshwater ecosystems, mostly during the Miocene epoch, thanks to research on their genetics. These are the platanistoids, consisting of the South Asian river dolphins in the genus Platanista, the lipotoids, which consists of only the Yangtze river dolphin, or Baiji, Lipotes vexillifer, which may have only recently become extinct sadly, the Ineoids, which contain the South American river dolphins in the families Ineidae, which includes the genus Inia, and Pontoporidae, containing the La Plata dolphin, Pontoporia blainvillei, which confusingly does not live in rivers. Not only are these groups not closely related to one another, neither are they thought to be that closely related to modern oceanic dolphins in the family Delphinidae. Some studies have even found the South Asian river dolphin to be more closely related to the beaked whales in the family Ziphiidae than to other quote-unquote dolphins. As you can imagine, this makes determining their relationships quite difficult, especially when we throw in a bunch of extinct taxa who also don't live in rivers and whose taxonomy varies considerably depending on the paper. As such, I'm just going to list and point out groups of odontocetes that emerged in the Oligocene that may or may not be dolphins or river dolphins, whatever that means, keeping in mind that many of these groups are liable to change. Of this peculiar bunch of cetaceans, the most common and widespread were the squalodontids, colloquially known as shark-toothed dolphins, as they are named after the shark genus Squalus. Known from all continents from the late Oligocene to the Miocene, they had long and narrow beaks with large protruding teeth. These teeth are distinctive in that all other odontocetes at the time were evolving simple, conical teeth throughout their jawline, whereas the squalodontids had heterodont dentition, that is, different types of teeth, which may have granted them a wide variety of prey. Despite this apparent success, the family seemed to go extinct in the middle of the Miocene epoch, suggested to be caused by competition with other odontocetes. The family Squalodelphinidae are a small and poorly understood group. While similar, they differentiated from the modern South Asian river dolphins by having shorter beaks. They appeared towards the end of the Oligocene and became extinct in the Miocene. The genus Arctocara of the family Allodelphinidae is noteworthy as it was discovered in late Oligocene sediments in Alaska, which, if also closely related to the South Asian river dolphins, would make it the northernmost known river dolphin, quote-unquote, despite being marine, living in subarctic waters at the time. The family first appeared during the Oligocene but became extinct during the Miocene. The Waipatiidae are another small and poorly understood group only known definitively from the late Oligocene Pacific Ocean. They would have resembled oceanic dolphins but with protruding, forward-pointing front teeth. These four families have often been considered platanistoids alongside the South Asian river dolphins. However, the paper describing Ankylorhiza and the accompanying cladogram removes many of the genera within these families, heavily rearranging the Odontocete family tree. Yet another curious dolphin-like group were the Eurinodelphinids. This group appeared at the very end of the Oligocene and became extinct at the end of the Miocene. They had incredibly long beaks, similar to a swordfish. Their relationship to modern odontocetes is unclear, with some researchers placing them close to the delphinoids, the group containing the family Delphinidae, the true oceanic dolphins, Phocinidae, the porpoises, and Monodontidae, the narwhal and the beluga. Much like the Mysticetes, by the Miocene epoch, all modern odontocete lineages had emerged, and they reached their greatest diversity during this time in the third and final adaptive radiation. Among the delphinoids, the bizarre genus Odobonoceratops of Sea Monsters fame was a strange odontocete from Peru with walrus-like tusks, yet possessed no other teeth. It was thought that the tusks, which were only present in male individuals, served as a deterrent and a sign of fitness to potential mates, and most likely were not for rutting or even defense. This odd cetacean, whilst once thought to have lived during the later Pliocene epoch, is only known from the Miocene. As well as the delphinoids, the elusive deep-diving Ziphiidae family, the beaked whales, first appeared during this time. They are still poorly understood due to their deep-sea habitat making them difficult to study. There is one last group of cetaceans I haven't covered yet, and those are the Physeteroids. This is the odontocete group containing the modern sperm whale, Physeter macrocephalus, in the family Physeteridae, and the Pygmaean dwarf sperm whales in the family Kogiidae, which first appear in the Miocene. The sperm whale is the largest known toothed predator ever. It is named after spermaceti, a waxy substance within the spermaceti organ, a huge sac at the front of the head that is either involved in generating sound or controlling buoyancy to aid in deep diving. Whilst the modern sperm whale hunts giant squid in the deep sea and only has teeth on the lower jaw, its extinct relatives were quite different in morphology and lifestyle. I spoke earlier about how mysticetes were hunted by the giant shark Megalodon. However, sharks were not their only predators. The macroraptorial sperm whales are an informal group of stem Physeteroids, more basal than all modern genera, that had enormous teeth on both the upper and lower jaws that specialized in hunting large prey. These animals were only named and described in the late 2000s onwards, very recent in the history of vertebrate paleontology. The smallest, Acrophyseter, was discovered in Peru and was around 4 meters long. Unlike the modern sperm whale, whilst it did possess the spermaceti organ, it was not thought to extend to the end of the snout, suggesting the tips of its jaws may have resembled a protruding beak. It would have fed on other cetaceans, pinnipeds, and maybe even Thalassochnus, a giant semi-aquatic sloth. No, I did not make that up. The largest macroraptorial sperm whale by far was Leviathan melvilli. Its name refers to the Leviathan from the Bible and Herman Melville, the author of Moby Dick. Whilst only known from the skull, comparisons with the more complete Zygophyseter have resulted in estimates ranging from 13 to 17 meters long. And what a skull it is! It has the largest biting teeth known in the animal kingdom, discounting tusks, at 31 centimeters long. It would have been an apex predator in its environment off the coast of Peru, feeding on smaller cetaceans, pinnipeds, and yes, it may have encountered and maybe even fought with Megalodon. However, note that large predators usually prefer to avoid one another, but I suppose it could have happened, and what an incredible sight that would have been. As impressive as these predators were, it is thought that they became extinct either at the end of the Miocene or the Pliocene due to the cooling climate from the oncoming Ice Age, altering the availability of their prey. Likewise, the megatoothed sharks also became extinct around this time, and the baleen whales began to grow to enormous sizes. It is still debated whether the Ice Age climate and rich polar waters drew the baleen whales away from the preferred warmer waters of the giant sharks and sperm whales, leading to their extinction, which in turn allowed baleen whales to grow much larger due to the lower threat of predation. Alternatively, the plentiful smaller baleen whales may have been the preferred prey of the large predators, and they may have been outcompeted by larger baleen whales appearing as the climate cooled. The sharks and sperm whales may have been robbed of their prey in this manner instead, or perhaps there was another cause for their extinction entirely. Cetaceans are some of the most incredible animals on the planet. Intelligent, diverse, and with a rich evolutionary history, they act as one of the greatest stories in the animal kingdom, starting with humble beginnings and ending in the largest animals the planet may have ever seen. Thank you so much for watching. Please do like, comment and subscribe, and I will see you guys next time. Bye bye now.